So under the compounds of boron, we have seen that boron forms a very important compound that is known as a diboron, that is a B2H6, where there are not enough bonding electrons are available to join all the atoms together in the molecule. So in case of diboron, we can find that there are two different types of bonds are observed. The 4 hydrogen atoms which are directly bonded to boron atoms, that is known as a terminal hydrogen atoms, and those bonds which are in between two boron atoms are known as a bridge bonds. And these bridge bonds are formed on account of 3 center electron pair bonds. Now I would like to show you how the bonding takes place. Just see this sharing. See this, these are the two boron atoms. These are the various bond characteristics which I have already shown. Here, these two bonds are formed on account of only 2 electrons, because here the requisite is of 4 electrons, but there are not enough bonding electrons are available, and hence the bridge bonds are formed, which is on account of 3 center 2 electron bond. That is the 3 centers, boron, hydrogen, and boron. Similarly, the boron, hydrogen, and boron, a single pair of electron binds all the 3 atoms together in the molecule. Now, another structure that I would like to show you here. One more structure which explains. Just a minute. Again, I will share this screen. I would like to show you the structure, how it looks. Structure of this diboron that I would like to show you here. So this is a structure of I think you might be getting my point here. The two boron atoms are shown. One is green, another is a pink, but both the boron atoms are similar. These are the 1s hydrogen atoms, orbitals of hydrogen, where sp3 hybridization is I have shown here, but only with 3 electrons. No 4 electrons are available. And here the common pair of electrons that is commonly shared, and these 3 atoms are joined together. Again here again shown the 1 electron from this boron, which is pink in color, 1 electron from hydrogen. And here the green electron from this boron, and green electron from this boron, and 1s electron from these hydrogen atoms. And here 1 electron from this boron, which is shown in pink color, 1 electron from this hydrogen. So only 2 electrons are available. Those 2 electrons bind all the 3 atoms, and they take a shape of a banana, and hence it is known as the banana bonds. Similarly, here 1 electron, that is green colored electron from boron, and 1 electron from this hydrogen, they share a common pair of electrons. The electron densities spread equally over the 3 atoms together in the molecule. So this is how one can see the formation of a diboron. Now we shall move further to the next, that is known as the borazone, borazine, triboron, triamine, or inorganic benzene. So there are 4 different words for another molecule of boron, that is B3N3H6. That is a triboron, triamine. That is a borazole or borazine. Again, you have to draw the diagram. with me. That will enable you for the better understanding of this borazole or borazine. Here, all these words you should remember. That is a borazine, or which is known as a borazole, borazole, or triboron, triamine, or it is also known as the inorganic benzene. MCQ type question may be asked, that is, which compound of boron that is referred as an inorganic benzene? It is known as borazine, borazole, or this B3N3H6. How can be prepared on laboratory scale? It can be prepared by using this diborane, that is thrice B2H6. In presence of ammonia, it can be synthesized as twice B3N3H6 plus 12H2. So this is a laboratory method of synthesis of this borazine or borazole. Now, borazole is referred as an inorganic compound which possesses a cyclic ring structure as that of benzene. So benzene is having cyclic ring structure, similar type of structure that is exhibited by this borazine. Here, this borazine also contains alternate single and double bonds, as we observed in case of benzene also. That is why it is called as a inorganic benzene. So I would like to show you the structure for this borazole and benzene. Now, this is a structure for benzene, and the structure for borazine is shown like this. This is a nitrogen, boron, boron, nitrogen, boron, nitrogen. So here alternate bonds are there. Similarly, in case of benzene, there may be alternate bonds are there. Here 6 nitrogen atoms are there. So BH, NH, BH, NH. So this is B3 and 3H6. 1, 2, and 3 boron atoms are there, and 3 nitrogen atoms are there, first, second, and third. So B3 and 3H6. So here there are alternate double bonds are there. Again, alternate double bonds are there, and hence this structure closely resembles with that of benzene, and hence it is known as the inorganic benzene. Now, in borazine, the 6 carbon atoms of benzene are replaced by 3 boron nitrogen pairs. So here carbon atoms are there in case of benzene, but here boron nitrogen first, boron nitrogen second, and boron nitrogen third. So 3 boron nitrogen pairs are replaced, which are present in carbon atoms as in case of benzene. Again, if we see the total number of electrons present in benzene having the composition as C6H6 carbon, so 6 carbon atoms are there, atom number is 6, that means 6 electrons are there, 36, and 6 hydrogen atoms are there, hydrogen having atom number 1, 6 hydrogen atoms are there, so 6. So if we make a total, then in case of benzene, there are 42 electrons are present in case of benzene. Now, calculate the total number of electrons in borazine. Boron, as we know, atom number 5, 3 boron atoms are there, so this is 15. Then nitrogen, atom number 7, 3 nitrogen atoms are there, so this is a 21. And 6 hydrogen atoms are there, having atom number 1, 6 hydrogen atoms are there, so 6. So this comes to be 42. So here again, total number of electrons in case of borazine are equal to the total number of electrons which are present in benzene. So this particular fact is known as isoelectronic with that of the benzene structure. So borazine is isoelectronic with benzene, because the total number of electrons in both the cases are similar, which I have calculated here. Again, if we look at the nitrogen atoms for borazine, for example, nitrogen atom number 7, 1s2, 2s2, and 2p3. The valence shell of nitrogen contains now 5 electrons, 3 plus 2, 5, because it belongs to fifth A group of the periodic table. So total valence electrons are 5. So here I would like to make again an elaborate structure. These are the boron atoms, these are the nitrogen atoms, and this is a boron atom. So here alternatively boron nitrogen atoms are there. So here this nitrogen can form, that is, this is a 2s and this is 2p, 2s2, 2p3. So nitrogen can form these three, first, second, and third. First, second, and third. These three bonds are formed on account of sp3 hybridization of nitrogen. But one lone pair of electron, that is from 2s, that is left here. So every nitrogen is having a lone pair of electron, which is contributed to form the pi bonds in case of this structure, and hence we can show the structure for borazine as like this: nitrogen, boron, boron, nitrogen, nitrogen, and boron. Here 6 hydrogen atoms are also there. So B3, N3, H6. Here we can find that alternatively double bonds are there. So here all the positions are not similar because of the electronegativity difference between boron and nitrogen. Boron is having electronegativity value 2.0, while nitrogen is having electronegativity value as 3.1. So when nitrogen gives its electron for the formation of this pi bond, nitrogen becomes positively charged while boron becomes negatively charged. So a dipole is observed. That means existence of two different poles. One is a positive pole, another is a negative pole. So this develops a polarity in case of this borazine, but in case of benzene, all the positions are occupied by carbon atoms. So the pi electron density, that is those electrons which are responsible to form the pi bonds, that is known as a pi electron density. That pi electron density is uniformly distributed as all the positions are alike or similar. Hence, there is no question of polarity. So, no polarity is observed in case of this benzene. But the case is not true in case of borazine. There exists a polarity. And because polarity is there, hence borazine nucleus undergoes addition reactions. But benzene nucleus is resistant to all the addition reactions. So benzene nucleus is not attacked by any acid. For example, if we treat this borazine B3N3H6, B3N3H6, then it can form here all the hydrogen atoms are replaced. Here 3 hydrogen atoms are replaced from the boron. These are here, here, and here. So it can produce a new compound as like this. This is a nitrogen, boron, boron, nitrogen, nitrogen, and boron. Here, this can form chloride atoms are attached with this like this. This is how, and this is nothing but this is NH2, NH2, and NH2. This is known as a trichloroborazine. So with HCl, borazine does not show any reaction. So in benzene, 6 pi electrons are uniformly distributed throughout the benzene ring. Since each point is exactly similar, this leads to the delocalization of 6 pi electron density. 6 pi means here 3 electrons are present for 3 bonds are present. So for the formation of 3 bonds, 6 electrons are required. So this is known as a 6 pi electron density. So in case of benzene, the 6 pi electron density is uniformly distributed. Hence, benzene nucleus is not attacked by any acid. But in case of borazine, the 6 positions are not alike because of the electronegativity difference. The polarity is developed, and hence this gives rise to polarity in borazole molecule, and hence borazole or borazine should be more reactive than benzene molecule. So borazine readily undergoes addition and substitution reactions. In contrast to this, benzene nucleus is very resistant to addition reactions. So this is how we can study the second molecule. Now, how the bonding is observed, just see here. I'm having how the bonding takes place. I would like to show you here. See here, this is a borazine where B3, alternatively boron, nitrogen, and boron, nitrogen. So there are 3 boron atoms and 3 nitrogen atoms. So B3 and 3H6 is there, and this is the resultant molecule. See here, the yellow color ball indicates that these are the boron atoms, and these blue color balls indicates the nitrogen atoms. So this is structure of B3 and 3H6, and here these dotted lines indicates the formation of double bonding. So the double bond may exist between this boron nitrogen pair or in between this boron nitrogen pair. So for this, a dotted line is shown in case of this. So this is how the borazole or borazine can be studied. So those 2 compounds that we have studied just now, one compound that is known as the diborane, another compound is known as a borazine. These 2 compounds are very important from the examination point of view, because of which the question, long type of question, or sometimes MCQ based questions may be asked on these 2 compounds. Now we shall move towards the next part of this, that is compounds of carbon. So after boron family, carbon family is there. As we know, carbon is exists in different physical forms. As we know that in case of this carbon family, as we know that carbon forms certain allotropic forms of carbon. The allotropic forms of carbon means the existence of the same element in different physical forms having different physical properties, but their chemical properties are similar. So the elements which are having the same chemical properties but having different physical forms, such different forms of the elements are called as the allotropic forms. So the allotropic forms of carbon are 2. More allotropic forms of carbon are there, we are going to study, but the 2 forms we have to study in more details, that is the structure of diamond and graphite. As we know, diamond is the hardest ever material found on earth. Diamond are used so as to cut the glass and the granite. Perhaps you might have studied in the cutting of glass, the small diamond pieces are used, or for the cutting of granite, these diamonds are used. So the diamond is having very high melting point of about 4000 degrees centigrade. So how the structure of diamond can be studied? Just see here. First of all, I would like to show you here the slide for this structure. Then I will show you how the structure appears. Yes. This is a structure of a diamond where I have shown this is the first structure, and here everywhere we can find that there are tetrahedrons are present. So the word tetrahedron indicates that in case of diamond, here the black balls indicates the carbon atoms. These carbon atoms, they undergo sp3 hybridization. I will show you how the sp3 hybridization occurs. Here a single tetrahedral unit is shown, and here when this unit binds with another tetrahedral unit, then this is the third step. And when all these points are occupied by diamond, then a three-dimensional network of fixed point is observed. So how can we see the structure for the diamond that we can study? Now, here I would like to show you the structure for diamond. See here the structure. Carbon undergoes sp3 hybridization, that we have to see. See here the structure for diamond. The graphite is also the allotropic form of carbon, allotropic form. Perhaps you might have seen the diamonds, and you are very well familiar with the graphite, that is the lead that is present in our pencil. That is nothing but it is a graphite. Now we are studying the allotropic forms of carbon. As we know, carbon having atom number 6, electron configuration 1s2, 2s2 and 2p2. Carbon is having 4 valential electrons. So for this reason, we always show a tetravalency for carbon. So to show the box diagram representation, this is a 2s2 and this is a 2p2. So this is 2s orbital, this is 2p orbital. So this electron is unpaired and it is promoted like this. So the excited state configuration becomes now like this. So 4 hybrid orbitals are there. So carbon undergoes sp3 hybridization, that is 1 2s and 3 2p orbitals undergo sp3 hybridization. Just now we have seen the structure for diamond. A single unit can be shown as like this. So everywhere we can find that carbon atom is there. So consider this central place carbon atom, which can form these 4 bonds with the surrounding 4 carbon atoms. So every carbon will contribute its 2s, 2px, 2py and 2pz electrons. So they share a common pair of electrons here and they can form the bonds. So in case of diamond, here by common sharing of electrons, so these are the electrons which I have shown, which are shared by the surrounding carbon atoms, and because of this, no free electrons are present in the structure of this diamond, and because of this, diamond crystal is bad conductor of heat and electricity, because to carry heat and electricity, free electrons must be possessed by any substance, because all the electrons are engaged in forming normal bonds with the surrounding carbon atoms, and hence diamond structure is extremely hard and tough. So this is how the structure for diamond can be studied. So if the question of the type, if it is asked that why diamond structure is a bad conductor of heat and electricity, your answer should be that in case of diamond, all the carbon atoms, they undergo sp3 hybridization. So all the electrons, 4 electrons, they are engaged in forming normal covalent bonds, and hence no free electrons are observed. Hence a diamond material is a bad conductor of electricity. You should use the word tetrahedron. So number of tetrahedrons are observed in diamond crystal. So there is a compact structure. I am having the compact structure to show you how the structure is compact. Let me show you. For this diamond, a very simple figure is there. See here, these are nothing but the red color balls indicates that these are the carbon atoms which are compactly arranged. Again, the three-dimensional structure. This is a three-dimensional structure. So this is a structure for diamond. Here, every carbon is tetrahedrally surrounded by 4 other surrounding carbon atoms, and because of this, the structure appears to be a compact. No empty space is there, and because of this, the bonding between the successive carbon atoms is very, very strong enough, and because of this, the material of diamond is extremely hard in nature. Now, if we look at the structure for graphite here, this is a structure for graphite. Here we can see the layer structure for graphite. In case of graphite, the similar type of structure can also be seen here. This is more clear. Here, a similar type of structure is observed for graphite, where every carbon, say for example, take for instance, this carbon atom which is placed at the center, which forms 3 bonds, first bond, the second bond, and the third bond. So every carbon can form 3 bonds with the surrounding 3 carbon atoms. So here, every carbon atom undergoes sp2 hybridization because every carbon that is having a single free electron. So graphite crystals are very good conductors of heat and electricity. This is because in case of graphite crystal, the free electrons are observed, and because of free electrons, the graphite structure can conduct heat and electricity. So if the question of the type, if it is asked that why graphite crystals are good conductors of heat and electricity, then you have to answer this, that in case of graphite structure, each carbon atom that undergoes sp2 hybridization, so each carbon atom that is left with 1 carbon atom, and because of which the crystal of graphite that conducts the electricity. So here every layer is placed one above the other. So while writing, by using your pencil, these layers of graphite, they slide over one another, and because of this sliding, we can see lines or the diagrammatic impression of the graphite material. So this is the main difference between the diamond crystal and the graphite crystal. So you must remember the point of differences between the diamond and graphite. Diamond crystal is hard, graphite crystal is soft. In case of diamond, sp3 hybridization is there, and in case of graphite, sp2 hybridization is there. Diamond crystals are bad conductors of heat and electricity, while graphite crystals are good conductors of heat and electricity. So these are the some points of differences between the diamond and graphite crystal. So in case of graphite, the carbon atoms are arranged in a hexagonal fashion. So you can find here, these are the hexagons. Number of hexagons are there, which are closely packed one above the other. So graphite has a layer structure, which I have shown here. Layer structure, this is known as the layer structure, where each carbon has undergone sp2 hybridization, and it is attached to 3 other carbon atoms. So you must remember, in case of diamond, each carbon is surrounded by 4 carbon atoms, but in case of this graphite, each carbon is surrounded by 3 carbon atoms with the help of a sigma covalent bonds in a planar arrangement. each carbon atom, so it is left with one electron, which is responsible to form, which is responsible to carry heat and electricity. In addition to this, the distance between the two layers of graphite crystals is about 3.40 angstrom unit. That is, this is a distance between these two layers, which is about 3.40 angstrom units or 340 picometers, which indicates that this structure is graphite structure is very soft, indicating very weak interactions between the two layers. The weak van der Waals forces which acting between the successive layers which are responsible for the soft nature of this graphite structure. So here, this distance which is shown here in this structure, here, these are the straight lines which indicates that there is a weak van der Waals process which exists between the successive layers. So this large distance explains that slippery nature of graphite. From this structure, we can reveal that the electricity, to conduct the electricity, this is a property that is related. So graphite crystals contain mobile pi electrons. No pi bonding is observed. So mobile pi electrons are observed, which can move from one unit to other unit, and because of this the electricity is conducted. So only 4 minutes are left. I would like to stop here, because if I continue with next point, I may not be complete that point. So you must study. After the completion of this topic, I will send you the notes for this topic. The previous topics notes are also, I'm going to make a PDF file, and that I will share with you. So today I'm going to stop here, and thank you very much.